Hi everybody, good morning. First of all, thank you for coming here. So in our talk now, I'd like to share with you our experience, a little about our history on accelerated data-driven culture in the largest media group of Latin America through Jupyter. Our company is globe.com. A little about us. We are both data and machine learning engineering that works in the most exciting teams, that's the big teams, of course, at globe.com. Now, before we go through talking about Jupyter, I'll try to explain a little bit about Global. By the way, I hope here those who have heard some information about Global.com, please raise your hands. No? No. One? Yeah. Oh, yeah. Oh my God. Cool. Interesting. I'll try to give you a few minutes an idea who is the Global.com. Basically, we were born digital to transform Brazil internet by crafting digital products, services, and operations for the largest media group in Latin America. Global.com is part of a big group of companies that's called Grupo Globo, that has a bunch of companies. Our mission is to deliver personalized content for users, to give interesting content and entertainment for our audience. Yes, we are a Brazilian company. Our main office is in Rio de Janeiro, but we have other offices in São Paulo and Porto Alegre. Some interesting numbers to have an idea. We have more than 87 million users. That's a great number, great audience. We reach 78% of Brazil internet. That means that for our persons that has access to internet, we reach 78% of them. We are leaders in video, sports, news, and entertainment in Brazil. So brings innovations and interesting products for our audience, our customers, and our services. Yes, Globo.com is 17 years of remarkable achievements. The first great product we have is the G1. That's a Brazilian largest news portals that deliver breaking news, local news, vertical content, and TV shows. G1 was launched in 2006, and 2000 it becomes the leader in Brazil with more than 50 million unique visitors and 1,000 new articles per day. And G1 is 2 times larger than runner-up. The coverage of G1 is impressive. We cover the Brazilian states with 57 newsrooms and more than 5,000 cities. Another great product we have is Globo Esporte. That's the abbreviation, GE. Since 2005, is the leading sports portal in Brazil that deliver sport news, live coverage about events, scouts, statistics. And another important point is that we are leader in 71% of sports category. Another great product we have is the Cartola FC. It's the biggest fantasy game in Brazil. It has more than 11 million of teams and more than 300,000 subscribers. Another great product we have is G-Show. All about entertainment you can find there, like TV shows, behind the scenes, fashion, interior design, receipts, and Big Brother Brazil. And yes, Big Brother Brazil is an internet phenomenon in Brazil. It's great impact, with more than 149 million numbers of votes in the single pool, 1 million of peak votes per minute. But to support these great products we have there, we have an internal solution to keep in track user event. We create our event tracker, we name it the Horizon. The basic idea is to capturing user data like page visited, watching time video, sharing news, comments on news, time reading the news, and scope percentage, etc. The basic idea is to get this information as fast as possible, make some simple transformation, and push down to the Kafka cluster. Behind the Kafka, we have Spark Streaming ETL that processes the whole Kafka topics and store in a Parquet format in our HFS cluster. Yes, lots of data, lots of challenges, and this led us to taking hard decisions. And hard decisions for us is based on data-driven. Our approach is data-driven development. We make our decisions based on what really works for the real people. It's the most important for us. We are doing many A/B tests for each interface changes, a button, a color in a button, this kind of stuffs. As a consequence of a data-driven process, we have a scientific bias with a fast qualitative cycles that giving a hypothesis, trying experiments and doing analysis, learn about the cycle and start again if it needs. But one thing is try to do faster is to deploy in production as soon as possible. That's the better way to know what really works for our audience is to put in the product our ideas. So using Jupyter with our big data resource and looking for KPIs, we can evaluate our user experience, design experience like a scientist. Yes, of course, Jupyter is playing an important role in the data-driven decisions. In fact, Jupyter Notebook are the heart of our data analysis process. In the Jupyter Notebook, actually, we are doing a lot of stuff, like performing A/B test analysis, machine learning experiments, performance evaluation of algorithm systems. And yes, we have a team focused on the personalization that involves implementing machine learning algorithms to system recommendation. Another team is a data scientist that evaluates the performance of the product, a growth hacking team that is doing as fast as possible solutions for making production. But why did we choose Jupyter? Why did you choose this tool for our data-driven support? Now, Diogo Munaro, you explain a little bit about
okay.
Oh, sorry, no, sorry, I forgot. Yes, okay. Before Munaro, we have some needs inside global.com that led us to Jupyter. The first one is the scalability. We have to, as a consequence of data-driven decision, more and more users, data scientists are interested in making data analysis. So we need to scale this process for hundreds of data scientists inside our company. Another challenge for us is analysis of large and complex data sets. We have lots of different data sets from different fonts, different sources. So it's very complex to deal with that. Another challenge for us that is we have people with different backgrounds inside our company. Different tastes, different feelings. We have people that prefer, loves R, but hate Python. But on the other hand, we have people that loves Python, but hate R. And also we have a third group that love both. So it's a complex scenario that we need to deal with. Yes, it's a great challenge for us, great needs. Another great point is the need of to make a collaborative work, to sharing knowledge and reproducible studies. So, due to this reason, this led us for Jupyter. That is its nature is to work collaboratively. Another great point is security. As we have a bunch of data sets, different data sources, and we have sensitive data like user information, email, purchased, and so on. So basically, we need to take control of the security in our ecosystem. So this is basically the needs, the main needs that led us to the Jupyter solution. But how do we match the needs with Jupyter? Now, yes, Munaro, you explain how we met the needs with Jupyter.
The slide is similar, so sorry. How we met these needs? So we will talk about that point that Philippe talked. So the first one is scalability for hundreds of data scientists. I don't know the fonts. Yeah, hundreds of data scientists. So we have a lot of data scientists in the company, and they can't use Jupyter Hub only on a single machine. It's impossible to scale for all of the data science. So we found that Jupyter Hub has spawners that work with Docker Swarm. Docker Swarm enable us to take a Docker for each user. So a user have your own machine and can make your analysis with your CPU and your memory. Another point is that we have a large amount of data. So when a data science came to our company, it got lost. So what about this? We have billions of daily events from users, millions of concurrent connections, millions of unique users per month, and hundreds of thousands of contents created by month. So there are a lot of content created here. And how can I analyze all that data? And how can I analyze it fast with a fast approach all of the data? So we found the Spark. Who here knows Sparks? No. Okay.
Great.
Great. It's a solution for better. I can use the resources in a better way and with parallel runs. So it's great because Spark loves Python and R. So Jupyter loves it too. And it's great for the another point that it should work with R and Python and both. So Jupyter and Spark solved all our needs for both, but there is a point. We have different kernels. We need Python 2 or 3 with Spark 2 or Spark 1. It's very hard to, in R with Spark 2 or Spark 1, it's very hard to the data science understand what it's going to do when it's come from our company. So we made some changes. We prefer to take only 3 kernels. But how we can customize all this with only 3 kernels for different versions of Spark? So we created an internal library called GlobalDS, and this library is helping a lot users to make an analysis and manage the Spark. I will show a little bit how users can manage Spark with this library and how it's helping our data science analysis at all. The good point that we did that library for R and for Python because we need to make all those happy. And
yes. One comment on that point is that the GlobalDS has 2 main functions. The first one is to simplify the data analysis process that brings some common functions for users. Another functions of this lib is to avoid misconfiguration as we have different data sources. So the data scientist needs to know what the exactly port of HFS service or the name node services or HBase services or even database. So it's very, very complicated. So the function of the GlobalDS is to simplify this process, to abstracting this configuration from data scientists.
Okay, thank you, Philip. So let's talk about this library. There are 2 main models. One model for Spark management and another model for data science utilities. So the first, how work the first model? We have 3 functions in this model. It's basically start Spark, and you can choose if you will start the Spark local, or you can run the Spark inside the Docker, or you can start Spark on the cluster. We have a Hadoop cluster, and the data science can submit jobs for that cluster. So when you need a harder analysis with a lot of data, and so it will be so slow to run locally, we can change to cluster. And with this function, you can choose what Spark version you will use. So you go to the kernel. When you go to the kernel, it's just a Python or R kernel. And when you use start, this kernel comes to be a Spark version of you like. Yeah. So another function is stop that stops Spark session. We stop Spark stop Spark for local or cluster. You stop the session in the context of the Spark. So your notebook comes to be a simple Python or R notebook again. And you can submit jobs like this. You can start using cluster and then stop and start local again.
One comment on, again, with this point that we have different approaches in our data science process. We have a statistical approach that we are sampling data. The sampling data sometimes can be heavy. And so our advice for data scientists is, so please go through our cluster and get the amount of the resource that you need and play. And yes, try yourself. It's better than run in a Docker. I forget. In a Docker, sorry. So this is our approach for that we implemented this function.
Okay, and the last function was monitoring, because we don't know how many times this job will spend. So we need to know. When you use monitoring, we send you a link, and you can see Spark UI and see the process, the number of executors, and how it's running. So you can control your submission of jobs and even local jobs.
The basic idea is to empower our data scientists to keep in track or in their Spark jobs. So they can track through the Spark UI. We just made a simple function that monitoring. We give a Spark URL UI, so the data science can keep track of that job.
Okay. And the other model was for giving a pattern for our data science. So when you need to, how could we call all the teams to make a pattern? It's very hard. So when we do some functions like remove outliers, that data science can just put a remove outlier your data frame and get back data frame without outliers. So we implemented these functions in R and Python. There are a lot of functions for removing outliers, they're simple. But other functions are plotting graphs. We have a lot of functions for plotting graphs to simplify data science. Date format, timestamp to date time, and it's very hard to do sometimes. And device type. Device type is a bunch of functions that guess what's the device of the user based on user agent, because you have a lot of different user agents and you need to know if it's mobile or desktop. So we try to simplify that thing. Save parquet and CSV files in HDFS, because sometimes data science needs to stop your work on some point and can save that file as parquet or CSV in a storage that's replicated, and it will never lost your data. So these functions help when data science wants to came again and work. Okay, data science can have your own environment, can make your analysis, but they need to install packages too, because GlobalDS can't be a bigger package that, no, we don't want it. So we can't provide the ability for data science to install packages by your own, because they sometimes don't know if the package is malicious or has any security problem. So what we did, there is a form that the data science put there the name of the package, the version of the package, if the package is on Git, and it should install that package inside the user Docker, and only the user Docker. And you can change that version. So I can work with a version of Matplotlib and another user using another version without problems. This installer works with Python and R, and we are using a whitelist for this package, of course, for malicious packages and etc. And install all these packages from our internal repository called Artifactory. Artifactory is a main product that you can buy and use. It clones our repos and Python repos, and you can use it inside your company without using external network. So, and the great of this safety package installation, it's because all is covered by Auth2 Authenticator. So all these steps are passing through authentication, and the user is always safe. So yes, the user can install package now, can make your analysis, but it's very hard to share that analysis. How could they share with other users or with stakeholders? It's very hard. Jupyter give you 3 solutions or even more for share using PDF, using links, or using HTML exports, but it's not so good. What we do is we use a mount point for each Docker, for each user Docker, with all notebooks. So every user can see all notebooks in the company. It's a mount point it's a mount point of any NFS file system, a shared file system. But if all users can see all notebooks, it doesn't make sense because it's not safe. So let's talk a little about safe. The last point of that global.com needs is security accessing data from different sources. So we have Google BigQuery, Solr, MySQL, HBase, HDFS, MongoDB, have a lot of sources inside global.com. And how user can access all these sources safely? So we have hooks. What we did? We did a file system for Jupyter that for each action that user makes, it's track this action. So when the user loads the list of notebooks, or when the user loads a notebook, we get all this information and send to Graylog. Graylog is our log server. It's open source. And we are tracking all this loads information. If the user run a cell, we send it to Graylog. You know what user run what cell. If a user deletes a notebook, we send it to Graylog. So we have all the user tracking here logged. But if you are thinking, okay, I'm getting this logged, but if the user did it, the user did, so I can get back. They deleted it. So we have integrations with Hook using auth2. We have a backstage account that's auth2 provider. Auth2 is a authentication mechanism. So we made authorization for each request. So if the user try to run the notebook, or if the user try to load the notebook, I will check with backstage accounts. That's our auth2 provider. If the user has permission to access that resource. So we have a file system shared. Do you know that it's not safe? But we have some mechanisms for control that access. So explain a little bit more this flux. When user try to access Jupyter Hub, ask it to backstage accounts can access, authorize it, get. If not, it's blocked. So this is our environment with all the stuffs that we talked about here. And here with Jupyter Hub that spawn a lot of Dockers and Docker for user, and the Docker has Jupyter with Spark, Python, R, sends all user tracking to Graylog, and is authenticated and authorized with auth2 our backstage accounts auth2 mechanisms. And now user can access safely all this resource and can make your analysis with any problem. So I want to thank you because you are here, and thank you for JupyterCon for the opportunity and our sponsors. If you want to know more, or want to talk about us, talk with us, you can get LinkedIn or email, and we will be able to ask you all questions.
Yes, but basically, by the way, we are totally open to working in new ideas in our open source community. So stay in touch with us. So add us in LinkedIn. We can talk about the innovations. So more important is our patience, me and Munad, right?
Yeah.
So thank you, and yes, we are open for questions.
So how does a user tell other users they can share their data?
How all user?
So you said you described the mechanism, right? How you get authorization to these resources. But once I produce my data, maybe I want someone else to actually use my data.
Yeah.
So
Yeah.
the resource has to be public somehow to someone else. And you have to say, okay, no, go.
Okay, good point. With backstage accounts authorize and authenticate all the company and all the global group. So we can just change the permission for that notebook. Do you know? So we make groups of access. So we can change that permission by group of access.
Yeah.
And
Just a comment. All of our services, the MySQL, HFS, are secured by the backstage account. So in the backstage accounts, we deliver the right permission for the user. So there is the right place when can change the user permissions. So the users can have access on this directory on HFS. Yes, okay, it's no problem. So it's a very integrated environment.
I have an APIs that's integrated with all the services and simplify user authentication and authorization.
Yeah, for me, it's like if I am the DOM user, right?
Okay.
Yeah.
I want to use the data, and then I just want to say, hey, buddy, you now want to go and look at it, right?
Yeah.
So I have to contact, you guys, the gurus, or I just go and click my button and say, oh, no, this is open to that other guru?
Yeah. Yes. It's the same idea.
Sometimes like this.
How many employees does Global have, and how many data scientists are you there?
How many data centers we have?
Yes. Yes. We have
One big.
spread data centers because our privacy policies, we can't speak in deep detail for you, but we have spread data center. But in Brazil, we have our own data centers, our own Hadoop clusters. Oh, sorry, data science. Sorry, data science, but it's.
Oh, sorry. Oh.
Sorry.
Okay.
I didn't get it. So data science is our assumption is that each person inside Global can be a data scientist, but in practice we have about 80 persons that is a data scientist. 80
No,
persons.
the cargo. No, the job
The
data
function.
science 8, but there all of the product managers or developers can access to. We have 200 of data scientists accessing the environment.
Yeah.
The last time we see.
Could you talk a little bit about how do you, when you do the Spark local node, you mentioned that the data scientist goes and kind of grabs it, it's like a subset that they're interested in. Is that how that's working? And moving it into the notebook before they run on the cluster? Is that the workflow you described?
When you get the data and run.
So what would you be, where's the data coming from when you're doing Spark local node?
Yes, from different sources, basically. But the main approach is our first advice for our data scientists: try in the small data. So internally we have another tool that we explain. We can't explain now, but we have a data extraction tool that is the main function is to make sampling data. So our advice for our data scientists: start with a small data. So it is basically is a interface to submit Spark job for our cluster, and after the process finish, this data are available in our HFS. So in the Jupyter notebook, the data scientists can access directly our Hadoop cluster, and yes, of course they can copy the data for the local file systems in the Docker. So they make some machine learning models, and the other approach is to use MLlib from Spark and run directly in our cluster, or even in the Spark standalone also. This is basically this approach.
But our data science are using BigQuery. We have our data cloned in BigQuery, and it's very faster than using just the cluster.
Basically, we are in a important mission now that is to brings the data to deliver the data for the other global group companies like Globosat, like InfoGlobo. Global TV is another separate company, but the same group. So the most appropriate tool that we chose was BigQuery. That is faster and very, very fast. That many data scientists know SQL can just make queries, ad hoc queries, and extract their data. So basically, we are go through this way at the moment. Basically, the Jupyter notebook is an interface to submit BigQuery queries and doing data science through that process.
Do you have a business case or a client problem that you can walk us through what the client came to you asking for and how you went about with it and how you involved the developers or you as a data scientist do all the implementation yourself?
Yes, we have many, and I'm so sorry to show it for you, but yes, we have many cases. We have basically we have G1, GE, G-Show are different products, are different teams, so they have different clients. Basically we are a platform for the global TV. So the global TV is that pay our salary. So they send the demands. So they say what we are doing wrong. So we get this feedback and try to analyze the data. And yes, we have an internal lab that we make some user experience experiments, like try to collect to select some persons, real persons, to just to put in the home and to see how this person navigating in our product. So, or the clickings, or the field expressions. So this kind of stuff we're doing, and we collecting also the data. With this data, we can analyze this behavior and crossing the different the data sources. For instance, we can evaluate the low subscriber rate from a product that's based on this data. So this kind of stuff. So there is many cases showcase, and I'm so sorry to not to show it for you.
Yeah, Cartola FC. That's the game that Philippe showed. Oh my God, that Philippe shows has a high engaged people and. But just a moment here. It's a soccer fantasy game. So when starts when the game open, we'll ever have a lot of people accessing, and to track that access, we need to build or track as soon as possible, and it's motivated to create a horizon to get user information as soon as possible, because Google Analytics has a lot of information grouped, and it's not so real time as we can do with Horizon. So
basically, this game is based on Brazilian football championship. So before each matches, the game opens, and each player can create their team with a cartoleta, that's a cache that each user has. They can buy players, and the behavior, the performance of his teams is based on the real matches. So it's very interesting game. So yes, as Munaro said, we have a great big data infrastructure to collecting this data as soon as possible, to take in place in our Hadoop cluster and processing this data and build recommendations and analytics in a real time. It's mostly probably in 10 milliseconds that data spends to at the moment that the user makes this action and this data arrives in our Hadoop cluster. It's very, very fast. So this basically is our scenarios of the big data structure.
okay.
Okay.